So welcome back, my fellow YouTubers. Today we will be picking back up with the event-driven API. Today we'll be focused on database setup and structure for a few of the services. Actually, we're just going to do the user service today. Let's not bite off too much. Try to make this video short and sweet. I also want to try pasting in the config or command line instead of typing them out, hoping to save time and make shorter videos. You guys let me know what you think down in the comments on which way you prefer. So we are going to use Docker containers for our database installations, but this Windows virtual machine doesn't have Docker installed, so we'll SSH over to the server that we installed RabbitMQ on, and we'll run Docker from there. So if you remember from the past video, is 192.168.1.131. Okay, so now we got logged in there, and so let's check and see if we have any running containers. No running containers right now. So what I want to do is our first container, let's actually create a Postgres container, and we'll set the password to Postgres. We'll name the container PGYT, and we'll expose port 54321 to the operating system so we can connect our application to that port. So let's go ahead and press enter on that. Alright, that's finished. So now if we do a Docker PS here, we have a Postgres database instance exposing port 5432 on the host port of 54321. Alright, so with that being said, let's go ahead and proceed to actually implement a database on there. So to get to that particular container, we want to do a docker exec -it and go ahead and write into PGYT, right? And in this situation, let's just go into the bash command, and if you notice here, our prompt change, you get this number which is the same as the container ID here, letting you know we're inside the container. So the next command we'll run is PSQL, but if you notice it says root user doesn't exist, so we need to do Postgres because that's the user that it creates. So right now we're logged in as the Postgres user in the Postgres database. So for this application, let's go ahead and create a database here. So the first few commands I'm pasting in is actually just some variables. So our database name is going to be EDA demo. We're going to have inside the Go configuration, we'll have a username of EDA Go, password is secret, and we're going to actually define a schema called app. So this next command I'm going to paste in here. My apologies. We're actually going to create a role based off of the app user, which is EDA Go in this instance, and we're going to create it with a password of secret, right? And so now, with that being said, the next command we'll paste in is creating the database. See, it's referencing DB name up here. The DB name is EDA demo, so right there we created the database. When you execute commands on Postgres, you will see it responds with the action and the action, and then also the entity or the thing you're manipulating there. And so now that we've created that database, let's connect to it. So how we do that is we come over to Postgres and we do connect. We're going to use the DB name. So now if you notice, the prompt changed here. So now we're actually connected to that new database. And so with that being said, we want to now create the schema. So I don't know why I keep pasting in the wrong commands. Forgive me. We want to create a schema, and the schema name in this situation is just going to be called app. And we're going to authorize the app user for this schema. So let's just execute that. Then the next command, we need to alter the search path for this user so that it looks at the app schema before it looks in public. So all these are Postgres database specific and kind of database generic commands and things like that. If you guys want me to go and do a video on database, just please post down below and I'll give you a little bit more detail. But specifically, this command is just telling it to search an app for a table name versus searching in the public schema first. By default, if you just go in here and start creating tables, they'll go into this public schema, and that's usually not a good practice. So you usually define a schema that's name is arbitrary, and you just kind of throw all your tables into that schema. This next command is pretty much going to tell Postgres like, hey, don't create any schemas on public, and also just revoke all data, all the tables and creation of tables on that public schema. And like I said, you can always see your commands because it repeats them back to you. And now we want to grant access to that schema. We want to grant access to that schema to the user we had created. So that's what this command is doing here. And now we gave it permissions to also create on that schema. So give this user the ability to create tables in this schema. And this last bit here is just to make sure we have default privileges on the app user so it can create its own objects and then actually has access to use them. Okay, so that's going to be about it in Postgres there. So now let's go ahead and go back over to our Golang app and build the connective code to interact with this database we just created in Postgres. So I normally create a folder and put all my schemas in a folder called models. So we'll go here and we'll create models, and since we're going to do this for the user service, let's just create the models for user. Also, there's going to be like a base model, so we want to actually put that in its own file just to kind of keep things a little simplified, and I'll talk these out as we're working through them here. So we're going to start with that. So we're creating a base models here, and we're just creating an empty struct. This will have a GORM model in it in a second, but I want to paste in the rest of this code, and then we'll come back and make our changes. So that's pretty much all the code pasted in. You'll see we have some red here under base, but that's because we need to install 2 new modules. So let's actually install those now. We need to install the GORM Postgres module, and we also need to install GORM's the base itself. So let's execute those commands and get that installed right now. GORM uses this table name function to name its functions. To name the tables. However, since we're using a schema, we want to prefix app onto the name. So app period and then the table name. So this function kind of handles that for us. So we kind of reflect it, get the name of the table. If it's a pointer, get the kind from the pointer, then reflect that name. And then get the name. We run it through the naming schema, which is a built-in method inside the GORM package that is used to create the name. So we pretty much go in there in reference that particular function and have it build the name for us, and then we just prepend the schema prefix on it, and then we lower it all. That's all this function is doing here. So now let's go to the actual creation of the tables, right? So this one is pretty straightforward. You can kind of get this from the GORM website, but the only difference we did is we were importing that app-based model as a type, and then we use the name of the table so that we can inherit some of these functions, so we can make sure we get that app schema prefix prepended to our table name. So in this situation, we're creating a user table and a login attempt table, and they are linked to each other with this login attempts with the foreign key login. We got one attribute there, user. Okay, so now the schema has been defined. Now, how do we actually use this? Well, to actually use this, we need to have a database connection. So let's do that next. Alright, so again, let's just kind of paste in a little code here. So we have a basic struct here that's going to take in a name as a string, host, username, password, port, and then as a whole the GORM database connection, and it also have a login component to it. And in this situation, we're going to use charm bracelet, so we're importing that as well. So let's go ahead and drop some imports in here. So this struct function connect is just used to connect to the database. And if you notice here, we have that app prefix or that schema in here so that it searches for that first. We actually put that in the connection string. We could have probably set that up as a variable as well, but in this situation, we hard coded it with app there. Then we're going to paste in the create tables function, right? And so this function is here just pretty much to literally create those tables. So let's add the import for models. Please removes the red under models here. And then let's just finish this function. So the rest of this function is just a for loop to iterate through whatever's in this list or slice of tables and then create it. And so it gives a little log message of migrating tables if debugs in there, right? Then next I have an init function that just, once we create an instance of this struct, we'll go ahead and call this init, and it'll connect to the database and create tables. Last but not least, we have a helper function here that takes the name, host, user, password, and port, and all its parameters, and then it returns this DB struct, this DB type, and then it'll call init and then return this as a pointer. So that's good. So let's go ahead and create us a test here. So inside of here, okay, so let's just create this function. So let's just paste all this in. So all we're doing here is we just made this a main package, and we imported that DB, and then we just want to get the connection. This is good enough here to test our connectivity, and also what it'll allow us to do is make sure we got a connection to the database. So in here, if you recall, the get DB connection takes the name, which is the database name, the host. As you can see, we have 192.168.1.138 because that's our host running our Docker container with Postgres. If you remember from the script, we use EDA go as the username and then a password of secret. And then the port, remember we exposed 54321, and that should be good. So let's save that. Let's go ahead and try to execute it and see what we get. So we didn't get anything, so that means it worked. Now, how could we view these databases? Well, there's a couple different tools you can use. You can use tools like SQL or dbeaver. There's just a bunch of tools. To me, none are really better than the other ones, but let's use dbeaver for this instance. Let's go ahead and download that for Windows and get that installed so we can view our database. Okay, so you can see dbeaver finished installation. Now let's open it up. Okay. You can choose to share, not to share. It doesn't matter to me. Okay, so now we have dbeaver open, so let's create a connection here. And so, like I said, we're doing PostgreSQL right here. So we just go in here and define our information. So as you recall, right, it's 192.168.1.131. We did port 54321. The database is called EDA demo, right? And so the password or the user, remember we use EDA go as the user and secret as the password. So let's test it, see if we can get connected. Okay, so it's saying it does not have Postgres libraries installed since dbeaver is a Java application, so it just wants to download those. So if you get this message, go ahead and just download them. Now you see it ran the connection test, it finished that, so you see it connected here. It says Postgres 18 and it's using this driver here. So all this looks good, so let's go ahead and finish. Now if you see here, we got EDA demo on 192.168.1.131. Here, if we expand that, look in databases, check this out. We got the EDA demo, but we created that via the command line. What we're looking at is, remember our schemas? Up there goes the app. Remember we were talking about app, but then most importantly, the tables. So you see our Go code created users table. See first name, last name, username, email. If we go back over here, right? First name, last name, username, email, password. You got a raw password. I'll explain some of that later, and you'll see that as we progress through the app a little bit and see my logic there. No foreign keys on users. So let's go to login attempts here. And we do have a foreign key for login attempts, but more importantly, we have, the same fields, right? Created, updated, deleted, source IPs, issue, user ID. So these same fields now, you might be wondering, like, okay, Kendrick, we don't see created, updated at, deleted at as lines in this particular database. You just have first name, last name, username. But remember, we did inherit from this app-based model here. If we go to app-based model, if you recall, I put this GORM model here. Well, GORM model, if we hover over it, VS Code actually tell us it has created at, updated at, deleted at ID as the primary key. So that's where we're picking up those extra fields from. So you can use standard inheritance with Go for these structs to be able to build database tables and schemas. So it's pretty cool. Now, you might be wondering, okay, so how do we add some data? So let's do that next. Actually, we don't have to create anything. Let's just go back to the main file here. Okay, so let's paste in a little code here. Okay, so let me explain a little bit what we got going on here. So we already ran where we connected to the database and it came out successful. So now what we're doing here is we're creating a user called John Doe. And John Doe's email is John Doe anonymous password secret 1. Then we create a Jane Jones. Our username is jjones5 password secret 0. But on Jane, we want to put in a few login attempts. So we got a few, 1 false, 2 trues, and a false attempt, right? And so then we use the standard GORM again in our database connection. We expose con because it's uppercase, and that's GORM DB, and we're going to just use the create method to create these rows inside of our database, right? And so here we're just writing out, okay, error creating, can't spell, error creating user 1, error creating user 2 down here, and a lot of copying and pasting there. And user 2, error message here if we have an issue creating user number 2. So let's run this again, see what we get. So don't get anything because we didn't save it. Try one more time. So here we can put our new line character. So here it says created user 1 at, here's the time, and it said it successfully created user 2 ID 2, and here's its time. So let's go into the database here and let's see if we see any of this. So let's go to users, click on data here. It's a tab across the top. Just click that, and there you go. We have John Doe, username jdoe1, password secret 1, jdoe, anonymous Jane Jones 1992, does this exist.com. So we actually got the records created. Pretty cool, right? So Jane, we actually attached some login attempts. So let's close users and go over here to login attempts and look what we have here. We got Jane, login attempts, and we have our association because if you notice, all these say user ID 2, which it cool thing about dbeaver here, it brings up and shows you inside the user table who is user 2. So in this case, we're talking about Jane here. Pretty cool, right? Just like that. So we're able to see that these were unsuccessful, but this one was successful. It looks like a little checkbox there. So that's us connecting to Postgres. Now, this video is getting kind of long, so I want to go ahead and create a different video for MySQL. So I'm going to go ahead and just wrap this one up. So again, just highlighting what we did today. So what we did was we created a Docker container, right, running Postgres database on version 18. We created a database schema inside of that Postgres instance, and then we also built some models, but more specifically, we inherited from an app-based model to give us some inheritance properties as well as mark our schema prefix there. And so we also created a user table and a login attempt table that inherit from both of those from the app-based model here, and defined our SQL based off of things here in Go. Then we also created a few users in our database here, right? And we added those to the database, in which is all reflected here. We have a 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. So, if you guys like this content, leave me a like, subscribe, smash the notification button. Let me know. Give me some feedback in the comments there. All feedback is welcome. Just trying to get in the rhythm here. So yeah, until the next one, which I should try to release on the same day, but it may be a day later, but we're going to do a MySQL. So thank you for joining. Again, have a good day.